Imagine you wake up tomorrow morning, you stretch, and you try to get out of bed.
And you can't. Not because you're tired, not because you hit snooze too many times, but because, suddenly, you weigh 300 pounds. No warning, no explanation. Overnight, gravity doubled.
So, what happens next? I mean, to you, to the buildings around you, to the entire planet? Well, the answer is honestly pretty terrifying. And in this explainer, we're going to go through it second by second to really understand the massive forces at play here. All right, let's dive right in.
The very instant gravity doubles, every single object on Earth gets radically heavier. Let's just tick through the instant impact here. You? Doubled. Your car? Doubled. The Eiffel Tower? Doubled. The ocean? Doubled. But here's something you might not think about right away. Your body just isn't designed for this. See, your skeleton, your muscles, your heart, they evolved for 1G, not 2. The average person would literally feel like they're being crushed under another version of themselves. Just standing up becomes a serious, monumental physical challenge. Walking, that would feel like carrying a full-grown adult on your shoulders constantly with every single step you take. But it gets worse.
Think about it. Your heart pumps blood upward against gravity. So, double gravity means your heart has to work twice as hard just to get blood to your brain. People with any cardiovascular weakness, and we're talking hundreds of millions of people globally, go into immediate distress. And here's a kind of fascinating detail. Tall people, they actually have it the worst. More height simply means more distance for that blood to travel upward. It's exactly why astronauts returning from zero gravity need time to readjust.
But in double gravity, there is no adjustment period. Your body just fails. Within the first few minutes, emergency rooms worldwide would be completely overwhelmed. And the hospitals themselves, well, they're in terrible trouble too.
Because every building, bridge, and structure on Earth was engineered with one fundamental assumption baked right into the math. Gravity is 9.8 meters per second squared. Double that, and suddenly every single structure is carrying twice the load it was actually designed for. Take the Burj Khalifa, for example. It weighs roughly 500,000 tons. At 2G, that is effectively 1 million tons just pressing down on its foundation.
Now, skyscrapers are designed to flex and sway, but they'd be facing forces they were never meant to handle. Most high-rises would probably survive the first hour, but older buildings, especially anything without modern earthquake resistance design, they'd begin to crack and buckle almost immediately. Over days, foundations shift, concrete fractures, bridges sag, suspension cables snap. We would see a global wave of structural failures unlike absolutely anything in human history. And the roads? Asphalt and concrete would buckle under the doubled vehicle weights. Trucks that were already pushing road limits become absolute pavement destroyers. Transportation definitively grinds to a halt, supply chains completely collapse.
Let's move to a completely different system and see how this builds. Here's something most people don't consider. The atmosphere has weight too. At 2G, the entire column of air above you presses down twice as hard. Air pressure at sea level would roughly double. It'd be very similar to what you'd feel, diving 30 feet underwater. Now, the good news is there'd still be oxygen. The bad news? Everything else goes totally haywire.
Weather systems are driven by pressure differences and the movement of air masses. So, double gravity compresses our atmosphere into a thinner, much denser layer. Storms would be more intense, but shorter in vertical reach. Hurricanes and tornadoes would behave in entirely unpredictable ways. And rain? Rain would fall harder and faster. Imagine every single raindrop hitting the Earth with double the force.
There's also a hidden impact on our water systems. Evaporation actually slows down. Why? Well, because water molecules have to work substantially harder to escape the surface. The entire hydrological cycle, the way water moves around our planet, fundamentally changes.
Now we go deeper. Earth's interior, the crust, the mantle, the core, exists in a state of delicate pressure equilibrium built up over 4.5 billion years. Double the surface gravity disrupts that balance catastrophically. The crust would compress inward. Rock that's been stable for millions of years suddenly shifts. Fault lines that were locked in place start slipping. We are talking about global, simultaneous earthquakes.
Every tectonic plate on Earth would be under extreme new stress. The Ring of Fire, which already accounts for 90% of the world's earthquakes, becomes a ring of constant, unrelenting catastrophe. Volcanoes, which are essentially pressure release valves for the mantle, would erupt en masse as the interior of the Earth struggles desperately to find a new equilibrium.
Over weeks and months, the physical shape of our home would alter. Earth would actually become denser and slightly smaller in diameter as the whole planet compresses under the incredibly increased gravitational force. The oceans would be pushed harder into ocean basins, meaning sea levels near coastlines would completely shift as the seafloor itself deforms.
So, who survives?
Well, large animals, including us, are in serious trouble. Evolution optimized our bodies for 1G over millions of years. At 2G, the energy cost of simply existing skyrockets. Plants struggle enormously too. Trees, which pump water from roots to canopy using osmotic pressure, would find that process fighting twice the gravitational resistance. Tall trees collapse or die. But smaller creatures, insects, rodents, reptiles close to the ground, they actually cope much better. Their bodies are already low-slung and structurally over-engineered relative to their weight. Low ground cover plants actually have a much better shot.
If humanity survived in any meaningful numbers, maybe in underground structures or low-altitude bunkers, our civilization would just have to look radically different. There'd be no more skyscrapers, no tall trees for lumber to build with. Agriculture would require completely new crop varieties just to sprout from the heavy soil. Literally every vehicle, every tool, every piece of clothing we wear would need to be entirely rethought and redesigned.
And space travel? Near impossible. The escape velocity from Earth's surface increases by about 41%. Getting a rocket off the ground would require vastly more fuel, making space exploration a distant, almost impossibly expensive dream. We would be profoundly trapped.
A doubling of gravity isn't just an inconvenience. It is a civilizational extinction event, reshaping geology, biology, weather, and everything we've built over thousands of years. The humbling truth we have to take away from this explainer is that life on Earth exists in a very, very narrow band of conditions. The exact strength of gravity we have right now isn't a coincidence. It's the result of a planet the right size, with the right mass, forming in exactly the right place. Change it, even by a factor of 2, and almost everything falls apart. Literally. If you found that journey as mind-bending as I did, consider subscribing. We explore fascinating questions exactly like this through our explainers every single week. It's an absolute joy to break these concepts down with you. So, drop in the comments, what force of nature would you want to explore next? Let me know, and I'll see you in the next one.